Okay, hello, welcome to the concept guide on section 5.5, Trapezoids. Please excuse the stain on my shirt, spilled some coffee earlier. I seem to do that all the time. Well, trapezoids. Trapezoids are a very special type of quadrilaterals. They are the only one that has exactly one pair of parallel sides. If it had more than one pair of parallel sides, it would be a, that's right, parallelogram. Good. The parallel sides of a parallelogram, of a trapezoid, we call bases. Now, what may feel a little bit weird about that is bases may or may not be on the bottom of the trapezoid, but the two parallel sides of the trapezoid are called bases. The non-parallel sides are called legs. Do you remember isosceles triangle where we had a base and then the two congruent sides were legs? Well, that's the same kind of idea here with trapezoids. The angles that share a base of a trapezoid are called base angles, just like they did with isosceles triangle. But there are two sets of base angles here in a trapezoid. Those are very important terms for us to be able to communicate effectively about trapezoids. Now, there is one very special type of trapezoid, and this is a very important part of our lesson. Oh yeah, I should go back here and remember that there are two sets of same-side interior supplementary angles because we have two parallel sides. So that's something that will help you get some answers right on some questions later on. Now, back to the special type of trapezoid. A trapezoid with congruent legs is called an isosceles trapezoid, like a triangle with two congruent sides is called an isosceles triangle. So that idea remains the same. Now, there ends up being a very important theorem with respect to isosceles triangles. The base angles of an isosceles trapezoid are congruent, okay? And that's always going to be the case, and this is very, very important for what we're going to be doing later on. Okay, base angles of an isosceles triangle are congruent, and then the next piece of this is one more term, a familiar term, one we've seen before, a median. And this is also very, very important for your understanding. The median of a trapezoid is the segment that joins the midpoints of the two legs. So the trapezoids that we have over there, you see the medians that connect the two midpoints of the legs. I want to compare these things to the median of a triangle, and you remember the mid-segment of a triangle. You should. Which one do you think the median of a trapezoid is more like? The median of a triangle or the mid-segment of a triangle? It's always been annoying to me. But we will continue. Now, there ends up being two very, very important ideas about the median of a trapezoid. The first one is that the median is parallel to its bases. Now, for the same reason that the mid-segment of the triangle is parallel to the third side. It's really the same concept as what we did in section 5.3. The other important thing about the median of a trapezoid is it has a length equal to the average of the length of the bases. Now, it'll take maybe a couple of run-throughs here before this makes some sense. So let's go ahead and look at these examples down here at the bottom, where it gives you some lengths relative to this base, which is 6, this base over here, which is 12, and then the median is x. So the way we can solve for x in this question is we will say that x is equal to 1/2 x plus 12, which is the same thing as 6 plus 12 divided by 2. This here is the more common form. When most people think of averages, they think of taking the average of two things, add them up, divide by 2. Well, adding them up and then multiplying by half, of course, is the same thing. Now, there's another way to think about these. If you'd rather, and sometimes it's advantageous to do this, if you take two medians and add them together, they will equal the sum of the two bases, which is just really a flipped way of doing the exact same thing. Let's look at this other example for just a second. They said here the two bases, x plus 12 and 7x minus 2, 1/2, which would be the same thing as adding them up and dividing by 2, is equal to the median, 5x. And then look at what they went and did. They multiplied by 2. So 2 of these, 2 times 5x, is equal to these two bases added together, which is why I said that it's really doing the same thing. So, or you could just go straight to this and write it this way. 5x plus 5x equals x plus 12 plus 7x minus 2. So you have some options here, as you usually do. Now, the other type of question that we're going to be seeing with respect to these isosceles trapezoids has to do with finding the measure of angles. Really, once you know one angle measure, you know all of the angle measures of an isosceles triangle, because they're congruent, or the base angles are congruent. So if this angle is 70 degrees, then this angle is 70 degrees. Now, how could we find the other two angles? Well, we know they're congruent. That's the fact about base angles of a trapezoid. But the other thing we need to remember is that we have that the four angles of a quadrilateral add up to 360. That provides a pretty simple way of figuring out what x is equal to. Or you can do what the book here did, is remember that because we have parallel lines, we have same side interior angles, which are supplementary. Now, on the other side of our sheet, we have some questions like what I will be expecting you to do, like what we just did in the previous examples as well. Let me just walk through the two of these with you. Number one here, if we're going to solve for x, we need to remember that 27 plus 33, these two bases, the sum of those, the average of those two, the sum divided by 2, is equal to the median. Or 2 of the medians, 3x plus 3x, is equal to the sum of the bases. That is the key to solving these. I'll let you finish the rest. Down here, we have an isosceles trapezoid, so we have base angles that are congruent. Then remember that we have same side interior angles here. So if this is 130 degrees and this is 130 degrees, then both of these angles, which are also congruent, are equal to 50. Pause the video at this point and give these other questions a shot. Here are the answers. Hopefully you got them right. If you didn't, see if you can figure out your mistake, or be prepared to ask a question. Now, how'd you do on number 7 down there? Well, really, the question is, you have an isosceles triangle. One of the angles is 48 degrees. So this ends up being just like number 5. It's just it didn't give you the trapezoid. So you have to go draw it yourself. That's not a big deal, unless you're lazy, which, never mind. Okay, the bottom half of our page has the other type of question, the other type of diagram that you're going to be seeing. Now, before we jump into this, look at what this diagram is about. We have a little triangle on top of a medium-sized trapezoid on top of a bigger trapezoid. If you put the blue triangle on top of the green trapezoid, we have a bigger triangle. This is a mid-segment to the bottom side of this triangle. If you put the green trapezoid on top of the yellow trapezoid, we have a bigger trapezoid, because these segments here are congruent, yn and nc, and then of course xm and mb. Mn is a what for the green and yellow trapezoid? That's right, a median of the trapezoid. So it will take the qualities that we were just talking about a moment ago. So to answer questions like this, let's look at question A. If we know all these things about this trapezoid, if xy equals 6 and bc equals 18, find mn. Well, what is xy? Xy is the top of the trapezoid. BC is the bottom of the trapezoid. XY and BC are bases. MN is the median. How do we find the median? Take the average of the two bases, which is what they do right here. Now, the other question that we have, it asks us it talks about xy. Well, if xy is equal to 12, what is mn? Triangle, mid-segment. Mid-segments are equal to half of the base, or the flip of that is the base is equal to double of the mid-segment. Go ahead and give these questions a try, and again, ask questions if things don't make sense. I'll display the answers in just a moment. There they are. I hope you did well, and I hope you're ready to ask questions if you have them. Tomorrow is another big day. Get some rest.